Definition of radioactivity. Radioactivity is the spontaneous decay or disintegration of the nucleus of an unstable atom with the release of any one, two, or all of alpha particles, beta particles, and gamma radiation with the release of energy. The term spontaneous means the process of decay of an unstable atom is not affected by external factors such as temperature, humidity, pressure, and so on and so forth. So examples of such elements which are radioactive are uranium, thorium, radium, boron, cobalt, radium, and many more. Now let us look at the types of radiation. Alpha particle. Alpha particles are emitted from the nucleus of large atoms. They are made up of 2 protons and 2 neutrons, which means it is the same as helium nucleus with an atomic mass or mass number of 4. So here you see a heavy nucleus emitting alpha particles. So you can look at the alpha particle and you see that it has 2 protons and 2 neutrons which are emitted. They move at a relatively slow speed compared to other radiation because of their sizes. So alpha particles, when compared to other radiations, they are slower. So what do you think happens to the nucleus after an alpha particle is emitted? Okay, you can pause the video and try that out. Okay, so I guess you're getting that right. So its mass number will decrease by 4 and the atomic number will also decrease by 2. Beta particles. Beta particles are also emitted from the nucleus of atoms. They are single electrons leaving the nucleus of an atom. So here you have an atom with a heavy nucleus emitting an electron from that nucleus. They move quite faster as compared to alpha particles. So when you compare them to the speed of alpha particles, they move faster. They are faster than alpha particles. So what do you think happens to the nucleus after the emission of beta particles? I guess you're guessing that right too. So its mass number remains the same, but the atomic number increases by 1. Gamma radiations. Gamma radiations are electromagnetic radiations which are released from the nucleus of an atom. So you can see that all 3 radiations or particles and radiation are all emitted from the nucleus of an atom. So here you have a heavy nuclide emitting gamma radiations in the form of electromagnetic waves. So as electromagnetic waves, they move at what speed? So what speed do you think they move at as electromagnetic wave? They move with the speed of light. Again, what do you think happens to the nucleus after gamma radiations from the nucleus of an atom? The mass number and the atomic number remains the same. So here let us compare the penetrating power of the 3 particles using a tin maker, a skin or paper, a thin aluminum sheet, and a thick lead block. So here you have the gamma radiations, you have the beta particle, and finally we have the alpha particles. Okay, from this simple activity, you can check the relative speed of the 3 particles emitted from the nucleus. So you can see that the gamma rays are faster and followed by the beta particles, then alpha particles. So the alpha particles can penetrate through a thin mica sheet, but they are stopped by a skin or by a thin piece of paper. Beta particles can pass through thin mica sheet, a skin or thin piece of paper, but they are stopped by aluminum sheets, while gamma radiations can pass through the thin mica sheet, the skin or paper sheet, thin aluminum sheet, and their intensity are only being reduced by the thick lead blocks. And this is because the gamma radiations are electromagnetic in nature. Now let us check their ionization properties. Ionization occurs when electrons are removed from an atom. A charged particle or charged particles will cause more ionization than neutral ones. A large particle is more likely to collide with electrons on their paths. So, with this information, rank the ionization ability of the types of radiation, so from highest to the lowest. So alpha particles has the highest ionization ability, followed by beta particles, and finally gamma radiations. So in that order, alpha particles, because of their masses and also because they are positively charged, they can easily ionize what atoms. Beta particles have less masses and are negatively charged, so they also contain charges, so they have less ionization ability than alpha particle. While gamma rays, because they are electromagnetic in nature, they have no mass and charges, they do not ionize particles on their paths. So let us look at deflection by electric fields. Alpha particles are attracted to the negatively charged plate. This confirms that they must be positively charged. Beta particles are attracted to the positively charged plates, and this shows that they are negatively charged particles. Gamma rays are unaffected by an electric field. They will just continue on their straight line path. So this shows that gamma rays means that they do not have charges. So here you can see the radioactive source, and the three radiations are emitted, with alpha particle slightly deflated to the negatively charged plate of the electric field, and beta particle widely deflected to the positively charged plate of the electric field, and the gamma rays undeflected. So let us look at deflection by magnetic fields. Alpha particles and beta particles are deflected by magnetic fields, confirming that they must carry charges. So it means that they both have charges. That is why they are deflected by a magnetic field. Beta particles are deflected by a magnetic field in an opposite direction to alpha particles. Gamma rays are unaffected by a magnetic field. Just like in electric field, gamma rays are also not affected by a magnetic field. This shows that gamma rays are charged, as they do not experience a force when passing through the lines of the magnetic fields. So here you see the source of radiation, and we have the radiative source placed in the poles of two magnets. Here you can see the alpha particle least deflected to the south pole, with the beta particle strongly deflected towards the north pole, and the gamma rays not deflected at all. They just pass through straight through the magnetic field, just like the electric fields. So let us summarize the types of radiations. So we have their names. The first is alpha particle, we have beta particle, and the gamma radiation. Their symbols: the Greek letter alpha, the Greek letter beta, and the Greek letter gamma. So their nature: alpha particles are helium nucleus. They have 2 protons and 2 neutrons. Beta particles are high energetic electrons, while gamma rays are high energetic electromagnetic waves. The type of charges: alpha particles have 2 positive charges, beta particles has a negative charge, while gamma ray has no charge. The atomic mass: alpha particles, the mass of an alpha particle is 4, beta particle has almost no mass, while gamma ray has no mass. Their speed: alpha particles are relatively slow compared to other radiations. Beta particles are faster than alpha particles, while gamma radiation, they move with the speed of light, which makes them the fastest radiations. Penetration power: alpha particles are stopped by a paper or skin. Beta particles are stopped by a few millimeters of aluminium. Gamma rays are reduced by a few inches of lead block. So what that means is that gamma radiation has the highest penetration power, followed by beta rays, and then alpha particles. These are due to the fact that the alpha particle is massive, very massive, and has a +2 positive charge. Then for beta particles, their masses are relatively small and they are negatively charged particles. As for gamma rays, because they are radiations, they are electromagnetic radiation, they do not have mass, so they have high penetrating power. And their ionization power: the ionization power of alpha is very high, that of beta is medium, and that of gamma ray is very low. So let us check these review questions.